Welcome to E-Chemistry presented by Fatima Convent High School, myself Dipali. Moving further with Chapter 1 Chemical Reactions and Equations. We studied what are chemical equations and what are chemical reactions, and we studied how to write symbolically the chemical equations and reactions. We studied balancing the chemical equations, and we studied various types of chemical equations like combination reaction, decomposition reaction, types of decomposition reaction, thermal decomposition, photodecomposition and electric decomposition, and exothermic and endothermic decomposition or endothermic and exothermic reaction. Now let us move further to two new types of chemical reaction. They are displacement, single displacement and double displacement. Now for that, let us go through an activity first. Take 3 iron nails and clean them with rubbing with sandpaper. Take 2 test tubes, mark A and B in each test tube. Take about 10 ml copper sulfate solution. Tie 2 nails with a thread and immerse them carefully in the copper sulfate solution in the test tube B for about 20 minutes. Keep one iron nail aside for comparison. After 20 minutes, take out the iron nail from the copper sulfate solution. Compare the intensity of the blue color of copper sulfate solution in test tube A and B. Also compare the color of iron nail dipped in copper sulfate solution with the one kept aside. Now you can see clearly in the figure the nail which was kept aside is still silver, while the nail which was dipped in the copper sulfate solution has turned brown. And the solutions in the test tube A and B has change in color. The solution in test tube B has faded away than solution in test tube A. What does this show? Why does iron nail become brownish in color and blue color of copper sulfate solution fades? Let us find out the reason. Now we know that iron, that is Fe plus CuSO4 gives FeSO4 plus Cu. In this reaction, iron has displaced or removed another element copper from copper sulfate solution. This reaction is known as displacement reaction. Other example of displacement reactions are Zn plus CuSO4 gives ZnSO4 plus Cu. Pb plus Cl2 gives PbCl2 plus Cu. Zinc and lead are more reactive elements than copper. They get displaced copper from its compound. So, if we try to understand the mechanism here, then the bond between Cu and SO4 is breaking and Fe is getting being positively charged is getting attached to CuSO4 by removing by SO4 minus 2 by removing the Cu plus 2 atom. So it became FeSO4 plus Cu. This shows that copper was displaced by Fe. So we can easily understand how the displacement reaction occurred. So it shows replacement of one element by the other, and this is called displacement reaction. Now let us move further to the double displacement. Double displacement reaction. Take about 3 ml of sodium sulfate solution in a test tube. In another test tube, take about 3 ml of barium chloride solution. Mix the two solutions. What do you observe? You will observe that a white substance which is insoluble in water is formed. The insoluble substance is known as precipitates. Any reaction that produces a precipitate is known as precipitation reaction. Na2SO4 plus BaCl2 gives BaSO4 plus 2NaCl. Here Na plus 1 and SO4 minus 2. The bond is breaking and the bond between Ba plus 2 and Cl minus 1 is breaking. Now we always have to remember that a positive ion can get attached to a negative ion. So Na will get attached to Cl and SO4 will get attached to Ba. So we get compound as BaSO4 plus NaCl, which shows that Na replaced Ba and Ba replaced Na. So it is a double displacement reaction. The displacement occurred twice, as termed double displacement. Now, what causes this white precipitates of BaSO4 to form? What causes this? The white precipitates of BaSO4 is formed by the reaction of SO4 minus 2 and Ba plus 2. The other product formed is sodium chloride, which remains soluble in the solution. Such reactions in which there is an exchange of ion between reactants are called as double displacement reactions. Let us take one more activity. Now we are going to refer to the activity 1.2 and try to elaborate that activity further. Now where you have mixed the solution of lead nitrate and potassium iodide, what was the color of the precipitate formed? Can you name the compound precipitated? Write the balanced chemical equation, and is there double displacement? So we can easily answer these questions. What was the color of the precipitate? The color of the precipitate was yellow. Can you name the compound precipitated? Yes. Now we know that it is lead nitrate. So PbNO3 twice plus potassium iodide Ki. Now we know that the bond between Pb and NO3 and K and I will break. Pb is plus 2, NO3 is minus 1, K is plus 1 and I is minus 1. So positive will join to negative and negative will join to positive. So can you tell me where Pb will join? Yes, Pb will get bonded with I, and taking care of the valencies, it will be PbI2. Isn't it easy? Plus, now K plus and NO3 minus 1. So it becomes KNO3. So the compound which is precipitated is lead iodide. Write the balanced chemical equation. So let us check the balancing now. Now we know how many atoms of Pb? 1. NO3 2. K 1. I 1. Pb 1. I 2. K1 and NO3 1. Now if we try to observe, the number of NO3 is more and number of I is highest. But we go for PbNO3 according to the rule because number of atoms in this compound are highest. So to balance NO3, I have to multiply on the right hand side by 2. So I get 2K and KNO3. Now to balance the potassium, I'll have to multiply the left hand side with 2. So I get 2I2. Is it balanced now? Yes. So the balanced equation can be finally written as PbNO3 twice plus Ki gives PbI2 plus KNO3, and the balanced equation will be by writing 2 here. This is the balanced chemical equation. Is it double displacement? Yes. Why? Because Pb and Ki both are replaced, and so it is a double displacement reaction. I hope this concept has become very clear to you. For today we shall stop here, as the next topic is little bit tough, as well as it needs little bit more elaborated explanation. So see you soon with the next topic, redox reaction or oxidation and reduction reaction.